In this video, we're going to learn about average atomic mass. So let's say that we've got this sample of chlorine atoms, and we're asked the question, what is the average mass of an atom in this sample? Well, for the chlorine atoms that have 18 neutrons, this is chlorine 35, and you can see there are several of them. There are also some with 20 neutrons, and they're chlorine 37. And so if we wanted to find the average, what we would do is simply add up all the chlorine 35's masses and all the chlorine 37's masses and divide by the total number of atoms, which there are 8 of. And what we get is that the average mass is 35.5 AMU. Now, in chemistry, it's impractical to try to weigh and count individual atoms. They're just too small and way too many of them. So in chemistry, we use a weighted average. And a simple average, right? When I say average, you probably think back to middle school. A simple average is, say, when you just take all the terms, add them up, and then divide by however many different terms there are. So if you had 35 and 37 and you were trying to average them, you just add 35 and 37 and divide by 2, and you get 36. But let's move towards a weighted average. How do you get a weighted average? Well, this simple average, we could re-express it as 1/2 times 35 plus 1/2 times 37. It's the same thing as what we had up here. And what this allows us to do is see it, well, instead of saying 1/2, we can express that as 0.50 and multiply that times 35 and multiply also 0.50 times 37. And all three of these different ways would get us to the same answer of 36. But when we express it like this actually, that 0.50 is like saying 50%. The average of 35 and 37 is, well, considering 50% weight on the 35 and 50% weight on the 37. That means they equally matter. But if we wanted to, we could skew this a little bit. Maybe the 35 matters more, so we could make that 0.5 into like 0.6 and the 37 into 0.4. As long as they add up to 1, we're good, right? That's how we can do a weighted average, and you could actually use that to calculate your grade in many classes. You don't necessarily have the same percentage of participation grade in quizzes and tests and homework and so on, right? You would maybe weight one a little bit heavier than the others, right? So before we move on, I want to address what percent abundance is. And this is just the percent of all atoms that are of a certain isotope. And what by that, I mean, let's say we go back to our original sample. In this sample of 8 atoms, 6 were chlorine 35. So 6 out of 8 is 75%. And our chlorine 35's percent abundance would be 75%. There are only 2 atoms of chlorine 37 out of the 8, so 2 out of 8 would give us our 25% abundance of chlorine 37. All right, we're ready to do a calculation. So if we know that, in truth, 75.76% of all chlorine is chlorine 35, which has an atomic mass of 34.9688 AMUs. This is actual reality. And we also know that 24.24% of all chlorine is chlorine 37, which has a mass just under 37 AMU. So if we're trying to find the average atomic mass of chlorine, all we have to do is just take the percent abundance of chlorine 35, change it to a decimal by dividing by 100, and then multiply that by its atomic mass, and that's what we see here. And then we're going to add the 24.24% converted to a decimal of the chlorine 37 times the mass of chlorine 37, which is what we're seeing here. And when we add those together, we get 35.45 AMUs as the average atomic mass of chlorine, which, if you look it up in the periodic table, is exactly the average atomic mass of chlorine. So I hope this video has helped. Feel free to leave any questions or comments in the comments section below. Thanks for watching.